All right, I'd like to welcome everybody to the 10F Notes. Big exciting day today because my third period class is going to join us for the notes today. We're doing them live studio audience style. Guys, say hi. That's hopefully that. Okay. Hopefully that's the last time many of them talk. Um, all right, so first we're going to list everything we know about sides and angles of trapezoids. We're not going to list things that we know about quadrilaterals, things like, the interior angles add up to 360. That's true for all quadrilaterals. It has four sides. That's true for all quadrilaterals. So we're going to try and just list the things that we know specifically that are specific to trapezoids, okay? One specific thing to trapezoids is that it has one pair of parallel sides, okay? That's one thing we know specifically about a trapezoid. Other than that, we don't know a whole lot about the sides. Something we know about the angles of a trapezoid, because it has parallel sides, it has two pairs of supplementary angles. So if we were to draw a generic trapezoid, angle 1 and 2 would be supplementary, and so would angle 3 and 4, and that's because of what we know about parallel lines. All right? An isosceles trapezoid, we get a little bit more information. The same things that are true that we just saw, but we also know now that the non-parallel sides are congruent. Okay? We know that both sets of base angles are congruent. And the diagonals over here, the diagonals are also congruent. Okay? So those are all things we know about an isosceles trapezoid. So some trapezoid examples, some basic problems that we can do. And then it's important to always notice directions. It's isosceles trapezoid examples. So for example, the examples, I'm going to say example 7 more times. Not now. Count them while you watch. My class will be counting, and when they get stuck, we have calculators, so we'll be fine. On the first one, if it's isosceles, we know that x equals what? 7. Very good. Only one person in the room knew it, but he's my favorite student. Okay. And over here on the side, on the right side, this is where we get into the base angles. If you think of this as an isosceles triangle where the top has just been cut off, when we had an isosceles triangle, we had these base angles down here were congruent. Well, that same phenomenon exists in isosceles trapezoids. So that is congruent to that. So we know that C equals 42. And then we know from all trapezoids that these angles here, and here, that they are supplementary. And we know that A and B are the same. So we can say A and B equal 180 minus 42, which is 138. Very good. All right, let's take a look at the problems on the bottom. Get a little bit more complicated with some algebra now. If AD is 3x minus 5, I'm a big fan of labeling, and BC is 2x, find x. It's isosceles, so we set them equal to each other, and we get x equals 5. On the bottom middle one, AC, this diagonal right here, is 2x minus 1. And BD, this diagonal right here, is x plus 2. If we set those equal to each other, because the diagonals of a trapezoid are congruent, we get x equals 3. On the bottom right one, if the measure of DAB, this angle right here, is 60, and the measure of ABC is 3x plus 15, find x. Well, those are base angles of a trapezoid, so they're congruent. So we set them equal to each other, and we solve, and we get x equals 15. Very good. All right, let's take a look at the next page. The median of a trapezoid. So if we have a segment, like this segment here, EF, that connects the midpoints of the two sides of a trapezoid, then we can find its distance simply by taking the average of the other two bases. It has two bases because you don't want to say top and bottom, because I could easily flip over the drawing and the top becomes the bottom. But if we average the two bases, then we get the median. Okay? Average the two bases. So add them up, divide by 2. So let's take a look here. Really, really pretty simple. The first one, the average of 25 and 15 is 20. Okay. I like, you can set this up algebraically and do it, this second one, but if we can understand what median means, that median, both algebraically and geometrically, it's the middle, okay? It's something to do with the middle. So from 26 to 20, we went down 6. So go down 6 more, and you get x equals 14. All right. The last one is probably the hardest algebraically, okay? Here we have to understand that if we add up the two bases, so 6x minus 10 plus 4x minus 6, and we divide it by 2, that we get the median. Okay? So we're going to add the two bases, and it's the same thing we did on this problem, and it's the same thing we did on this problem. Here, there's just algebraic expressions, so we have to show a little bit more work. All right? So we have, this is 10x minus 16 divided by 2 equals 3x plus 4. I can divide 10x and negative 16 by 2, so I get 5x minus 8 equals 3x plus 4. Add 8 to both sides, get 12. Subtract 3x from both sides, get 2x. 2x equals 12, so x equals 6. No one got that one. One person did. But he lies sometimes, so we're not going to take his word for it. All right, let's take a look at what's next. Kites, okay? Kites. Everything you know about the sides and angles of a kite, okay? The sides, we know that it's got two pairs of adjacent congruent sides. Okay, so a pair of sides next to each other that are congruent and another pair. The angles, we know it has one pair of congruent angles. And the diagonals are perpendicular. One other thing about the diagonals, not only are they perpendicular, but they bisect the non-congruent angles. Okay? They bisect the non-congruent angles. Okay? So let's take a look at a kite. For a second, before we start, I'm going to take those properties that we just talked about and make sure we understand what they look like when we're actually looking at a diagram. So we have congruent angles. P and R are congruent. Okay? The diagonals are perpendicular, so that's a right angle. The non-congruent angles are bisected by the diagonals. So those are congruent and those are congruent. And then we have two congruent sides and then two other congruent sides. So those are all the properties of a kite. It might be worthwhile to either label yours somewhere or draw it on there just so that you're clear on everything that we know about a kite. So let's take the example problem that we're given here. So PQ is x plus 10. You also notice, by the way, or you might or may or may not notice, in a kite we have a right triangle and another right triangle. We have two right congruent triangles, and then we have two more on the bottom. These are both congruent right triangles. So all sorts of things that you know about right triangles we might be able to use when working with kites. Hint, hint. So we have x plus 10 for PQ. We have QR is equal to 4x minus 5. And we have PS is 6x minus 5. And the directions say to find the lengths of all the sides. So we're going to solve for x and then find the lengths of the sides. We're going to solve for x by setting the two congruent sides equal to each other. So we get x plus 10 equals 4x minus 5. So x equals 5. So PQ is equal to 15. QR is equal to 15. And PS, 6 times 5 is 30, minus 5 is 25. And obviously, just for fun, RS is also equal to 25. Okay? Let's take a look here. So another kite, just more examples of things we can do. If KIT, this angle right here is 74. Okay, that angle right there is equal to 74. And KET, this whole bottom angle is 36. Okay, that whole angle is 36. We're going to find IKS, okay, which, just to be clear, IKS is this angle. We're going to find SKE, which is this angle, and we're going to find ITE. Okay? So the first thing I'm going to do is I'm going to make sure that I understand what we're saying here. Because of what we know about a kite's angles. If this whole thing is 36, I know that the diagonal bisects the non-congruent angles. So that means this is 18 and this is 18. If this is 74, then here is 37 and here is 37. Then I know the diagonals are perpendicular, so I have right triangle information. If that's 37, then how much is left for right here? 53, good. And then what's left over there for ITS, for right here? 53 again, because they're congruent. Okay, let's see if that's enough to answer all of our questions. IKS, yep, we got that one, 53. SKE. So here, we didn't get that one. This is 18. This is a right triangle here also. So this is just 180 minus 90 minus 18, which leaves us with 62. Let's go 72. Okay. SKE is 72. And ITE, we have that one already. That's 53. Okay, so lots of right triangle information and things we can figure out with properties of kites. So here's a nice flow chart. We've done this sort of already once, and then this flow chart is nice and easy because the word that goes in the blank is the same shape as the blank. You're welcome. So this is similar to what we did in class where we had a flow chart of 10A. We did that today. So quadrilaterals over here on the right, I'm going to start with trapezoid. Okay, and then specifically what kind of trapezoid might I have? An isosceles trapezoid. Okay, we could also just have, generally speaking with quadrilaterals, we could have a parallelogram. That's, it's not a parallelogram, I don't know what that said. So we have a parallelogram. Then specifically we could have a rhombus. Right? We could have a rectangle. And if we sort of combine the powers of a rhombus and a rectangle, we could have a square. Okay, so we need to understand what that looks like as a flow chart. We also are given that to you in your notes as a Venn diagram, okay, sort of to bring back something from the logic unit. So if the whole rectangle was quadrilaterals, the most specific quadrilateral is going to go in the smallest circle inside. So we're going to put our square in there, okay, our square in there. Nice and neat. We said earlier, you know, that when we combined the two powers, you know, of two shapes, that's sort of how we got our square. And those two shapes were a rectangle and a rhombus. So there's our rectangle. And then our rhombus. I don't think it'll tilt that for me, but I can fix it. And then those are all kinds of parallelograms. And then we had two specific quadrilaterals that weren't in the parallelogram category, and that was a trapezoid. And then very specifically, we had an isosceles trapezoid. Go away. All right. And that, my friends, is it for today's notes. I appreciate you watching. I thank my third period for helping us out. Guys, give yourself a round of applause. That's too much. Stop. Stop. It wasn't that good. All right. Enjoy the notes. See you in class.